This is how we can we can efficient utilize this solar power. As you can see, this is a solar panel, and this is energy saver light that's being run by a UPS or inverter. So in this, first of all, there is a solar panel that is generating the electricity, that is DC electricity, and it is a buck converter or the buck regulator. So my purpose is to increase the efficiency of the system. In the practical application, we see there are the solar system, we are losing the power due to lack of due to the some inverters, converters. So we've lost maximum of the power there in the conversion process. How we can efficiently utilize this solar power and convert this into the normally house into 220 volt AC for the home appliances. So in this is a solar panel that's giving me nearly 29 volts on open circuit. So I am using a buck converter, and this is a buck converter that's converting my 29 volts into 7.5 volt DC, and I am feeding the 7.5 volt DC to this inverter. This is a UPS which have the built-in inverter, and this I'm using this inverter, and inverter is converting the 7.5 volt DC into the 220 volt AC. So let me check the voltage. This is a multimeter, and I set this DC voltage. Okay, let's measure the input voltage, the output voltage of the solar module. These are okay, and no, okay. These are 18.8 volts. These are the input voltage that are being taken from the output of the solar panel, and this converter is converting, this is the buck converter that's converting the higher DC voltage into lower one with the higher efficiency. So its output voltage is its output voltage is 7.63. Okay, and these voltages are being fed to this inverter, and through which I have connected the appliances. Now let's check the how I improve the current efficiency or the overall system efficiency. Let's set it to the current range. So let me measure the input current. This is 1.28. This is the input current. This is input current that's being provided by the solar module, and let's check the output current from this buck converter to the UPS or the inverter, and this can be measured from the output lead. This is much higher than the input current. This is 3.11 amperes. So this is much higher than the input current. So I just want to say that in some the inverters or the UPS system, they doesn't need higher voltage. For example, if there is an inverter, it needs minimum 10 volts to provide the power to these home appliances. So if we give the inverter the 15 volts, 14 or etc., if we provide any extra voltages, it means we are losing the power. If we convert the higher voltages into lower voltages, so using the buck regulator, we can save the power efficiently. So this is just a prototype, just to give you knowledge how we can efficiently utilize the power. Now, if we use a battery, uh, we can also save the power from the battery. If we have stored energy, uh, we can have the more power in the battery, or we draw the less current from the battery for the home appliances. And in this way we can have more time for the batteries. We can run our home appliances for more hours, for more time. In fact, we can increase the backup of the battery by using this efficient converter. So in my experiment was just to explain how we can efficiently utilize the power. Now this inverter just needs 7.5 or 8 voltages for the conversion. So thanks for watching. I hope you will find it useful. You will utilize this, and you will research it and find new things, and I will suggest you to explore it more. And I request you subscribe my video. Thank you very much.